Okay, so now that the meeting is now being recorded, hello, good afternoon everyone. For today's meeting, we will be solving for a problem regarding bolted connections that are subject to eccentric loadings. So unlike in simple connections wherein the loads are acting exactly along the centroid of your connection, this time that wouldn't be the case as there will be the presence of eccentricity now. So as for this sample problem right here, so bolted connection with eccentric loading. So this would be our problem. And in this problem, we will be determining the most stressed bolt in the group. So in this problem right here. So by visual inspection, we can say that this certain loading system right here is eccentric since both of these loads right here are not acting along this centroid right here. Confirmation everyone, do you see my laser pointer?
Yes,
Yes,
sir.
sir.
Okay, so ayan, ulitin ko lang, our loads right here would be eccentric because they wouldn't be acting along the centroid of this bolted connection right here. So from that itself, the first thing that we should do right now is to determine the centroid of these bolts right here for us to know its eccentricity. And once again, by visual inspection, we can conclude that the centroid of this system right here is to be in this location right here. Wait. So it would be this location right here. But since we are engineers, we should back it up with a solution. So for our solution, let's say that this bolts right here have areas of AB. So let's say that AB is to be the area of one bolt. And as you can see here, we have 6 bolts. So the total area of our system is to be 6AB. So 6AB. And let's say that this dimension right here is to be barred y, so y bar, and this dimension right here is to be your barred x, so x bar. So for us to solve for barred y, so the total area of our bolts times barred y is equal to the area moments of all of the bolts. So if we are to consider these two bolts right here, so by the way, let's solve for this barred y in reference to this axis right here, and let's solve for the barred x in reference to this axis right here. So okay, so from that once again, so for the first 2 bolts, that is to be 2AB. So we have 2 bolts right here times our lever arm of 0. And as for these 2 bars right here, plus 2AB times what would be its lever arm, it would be 75. So 75 mm. So plus, I would just be writing it here since we don't have any space, plus this 2 right here. So that is to be 2AB once again, times the lever arm of 75 plus 75, which is 150. So solving for barred y, since our AB would just cancel out, so hindi ko na ika-calculator, no? Our barred y is equal to 75 mm. Do you guys agree?
Yes, sir.
Okay.
Yes,
So
Yes, sir.
that's for barred y. So for our barred x, similarly, using this formula, so I would just be relocating it here, and I would be deleting this ones right here. And for our barred y, barred x, I should say. So 6AB once again. So this is to be the total area of all the bolts times barred x is equal to. So this time we would be getting the moments of the areas about this green axis right here. So as for this first 3 bolts right here in the left, so that is to be 3AB times what would be its lever arm is, so it would be 0. And as for this 3 right here, so plus 3AB, and its lever arm would be 75 mm. So 75 mm. This is to be 37.5 mm. So to prove it, i-calculator na lang natin. So 3 times, fraction pala muna natin, no? So 3 times 0 plus 3 times 75 divided by 6. So this is to be 37.5 Do you guys follow?
Yes, sir.
Okay, so ayan, and right, even before we have solved for this, we already know that the location for our centroid was already in this part right here, which is in, well, in the center of the bolts. Okay, once again, our centroid is to be in this part right here, which is exactly in the middle of 75 mm and in the middle of 150 mm. So the next thing that we should do is to determine the eccentricity of these loadings right here. So for us to determine that, let's just measure the distance from this point up until this point and this point up until this point. So let's say that this is to be EX and this is to be EY. So for our E of X, that is to be half of 75 plus 150. So 75 over 2 plus 150. So our EX would now be equal to, so 75 divided by 2 plus 150, that is to be 187.5. So 187.5. And as for ease of y, or our eccentricity in that direction, this is to be equal to, so 75 plus 60 mm. Mabuti nang sigurado, no? 75 plus 60, that is to be equal to 135 mm. So this is to be our eccentricity respectively. So do you guys follow? And are you guys following, I should say?
Yes, sir.
Okay, so ayan, eccentricity pa lang tayo. Okay, so when we are to deal with these kinds of problems, so this one on your left, you are to consider two types of stresses here. So the first one is what we would be calling direct shear and torsional shear. So this torsional shear is the stress that is brought about by the eccentricity. So torsional shear. And we would be discussing this later. So let's go straight to direct shear first. So for direct shear, so once again, this is to be your system. This is for direct shear. So for direct shear, since we are to consider this joint right here to be in static condition, so meaning these connections right here wouldn't move. So if our connection right here is to be in static condition, it is then in equilibrium condition. So if it is in equilibrium condition, we can conclude that the summation of forces horizontal is equal to 0 and the summation of forces vertical is equal to 0. And here, for us to get the values of direct shear, we are to consider that each and every one of these bolts would carry the same amount of load as brought about by these forces right here. So with those being said, let's say that this is to be your horizontal force. Okay, and we are to assume that all of these forces right here would be equal. And let's assign it as PH. So horizontal force, PH. And as for the vertical, it would be this one right here. So drawing ko lang ulit. So this is to be PV. And once again, we are to assume that all of these forces right here, all of these bolts would have equal magnitude in terms of their directions. So that is for direct shear. So for us to get the value of PH, summation forces horizontal is equal to 0. So summation forces horizontal is equal to 0. And we would be considering to the right positive. So as for the sign convention, it would be up to you. So matatanda na kayo, alam niyo na yan. So from that, we have 6 PH here. So 6 PH. So once again, we have 6 bolts carrying PH amount of load each. So minus, so this is to be 300 kilonewtons acting to the left. So negative 300 kilonewtons. So what else? So we don't have it. We don't have any forces anymore. So this is to be equal to 0. So solving for PH. So PH and transposing this negative 300 kilonewtons to the other side, that would be positive 300. So 300 divided by 6. So that is to be 50 kilonewtons. Do you guys agree? Do you guys follow?
Yes, sir.
Okay, so very good. So ayan, and for our PV, let's say that this is to be PV or the vertical force. So there, summation forces horizontal is equal to 0, and let's assume that upwards is to be positive. So with that being said, we have 6 PVs. So as you can see here, 1, 2, 3, 4, 5, 6. And we would be subtracting this load right here, which is directed downwards, so minus 200 kilonewtons. So this is to be equal to 0. And solving for our PV, so this is to be equal to, so transposing negative 200 to the other side, that would be positive 200 divided by 6. So our answer for our PV would be 33.33. So 33.33 kilonewtons. So this would be our direct shear. So are you guys following? Are there any clarifications? Questions?
Wala po, sir.
Okay, so very good. So let's go straight to this one right here. Since what I have said earlier that we are to consider two types of stresses here, so we already have done direct shear, and this time let's do torsional shear. So okay, let's go here. So for the torsion, because of the presence of eccentricity, which is once again this one's right here, so ito nga yung eccentricity natin, no? Because of these eccentricities right here, we would be having moments. So because of eccentricity, we have the presence of moments once again. And in this case, our moment isn't bending, and it is to be categorized as torsion because it would be in a twisting action. So let's solve for the torsional moment first. So let's abbreviate it as T, or torsion. So torsion about the centroid. So let's get the moment about the centroid. So that is to be equal to, by the way, let's say that clockwise is to be positive. So from that, 200. So 200 kilonewtons. So I will just be changing the color for you to understand it better. So 200 kilonewtons, so which is this load right here, times our lever arm, or the eccentricity of, so 150 plus 75 over 2, which is 187.5. So 187.5 mm. And how about for this? So for 300 kilonewtons, and as you can see, this force right here would act counterclockwise if this is to be your fixed point. So from that, this should be negative 300 kilonewtons times our lever arm of, so 75 plus 60 mm, which is 135 mm. Do you guys follow?
Yes, sir.
Okay, so let's solve for, so let's solve for the moment here. So 200 times 187.5 minus 300 times 135. So this is equal to negative 3,000 kilonewton millimeter. And I think it is better for us to divide this by 1,000 for us to convert this into kilonewton meter instead of kilonewton mm. So sulat ko na nga lang para hindi kayo malito. So this is to be negative 3,000 kilonewton mm. So meaning by this negative sign right here that this is to be in a counterclockwise direction, since the sign convention that I have chosen a while ago is to be clockwise positive. So torsion is equal to 3,000 kilonewton millimeter counterclockwise. And if we are to convert this into kilonewton meter, so torsion is equal to 3 kilonewton meter. So what I did right here is just to divide this value right here by 1,000 to convert it into kilonewton meter. So counterclockwise. So I would just be deleting this for us to have space. So since this is to be our torsion, which is counterclockwise, this means that because of these forces right here, there is to be the presence of a torsional moment along this centroid right here with wait, I will just be redrawing it. So this moment right here has a magnitude of 3 kilonewton meter, which is counterclockwise. And for our system to be at equilibrium, all of these bolts right here should resist this torsional moment right here. So kailangan nilang magtulong-tulong para makancel itong torsional moment natin. Do you guys follow?
Yes, sir.
Okay, how about for the others?
Yes, sir.
Okay, so ayan. So what we would be doing next is that I would be drawing a line from each of these bolts right here towards the centroid. So that is to be this line right here. So this one. Confirmation, guys. Can you see what I'm drawing?
Yes, po, sir.
Okay, so
Yes, sir.
ang ginagawa ko lang is that I am just drawing a line from the center of the bolts to the centroid of the bolt. So there, and after which you would be drawing a line that is perpendicular to these lines right here. So I would just be drawing a line here. So it may be this one right here or this one right here. So this would be the resisting force of your bolts. But as you can see right now, since this moment right here is in a counterclockwise direction, it means that your bolts should have forces that is acting on a clockwise direction for this to cancel. So from that, so it would be this one right here. So once again, guys, that this line right here is to be perpendicular to this line right here. So it would be this one and this one right here. Do you guys follow?
Yes, sir.
Are there any questions? So if wala naman, ulitin ko lang that this forces right here is to be perpendicular to this line that I have drawn earlier, which is a line directed from the center of your bolt, each of your bolts to the centroid of your bolt, which is this. And it is in this direction, not the other way around, but because their use is to cancel this torsional moment right here. So ayan. And guys, take note that every one of these forces right here has their own x and y coordinates. So what I mean is that, for example, in this line right here, this has a y coordinate and it also has a x coordinate. So x and y. And in this case right here, so as you can see, this line right here is directed vertically upward. So meaning, though it also has its own x component, it just happened that its x component is equal to 0. So there, and for us to determine, I would just be moving this one right here to this side so that, for us to avoid confusion. Okay, so for us to determine the x and y components of each of these forces, we would be using this formula. So let's say that this one right here is to be abbreviated as piece of t, so pt, and let's say that pt is equal to the shearing force as brought about by your torsional moment. So pt, so pt, and if we would be getting the x component of it, so ptx is equal to your torsion times y divided by the summation of the squares of the distances. So this distance right here is to be this distance right here. So from the centroid to each of these bolts right here, so you would be getting its distances and you would be getting its squares and you would be getting its summations. So summation of the squares of their distances. So it would be as simple as that. And as for this y right here, so itong y na to is to be this y component right here. So from the center up until that point that you are analyzing. So for example, kukunin mo yung dito sa una, it would be this one right here. So if you would be getting p t y, which is the y component, that is to be t times x divided by the summation of d squared. Okay, so what I would be doing now is that I would be labeling all of these ones right here. So in this case, sulat natin dito kasi wala natin space sa kabila. Let's say that this is to be bolt 1, bolt 2, 3, 4, 5, and 6. So there. So 1, 2, 3, 4, 5, and 6. And let's say that this is to be x and this is to be y. So via Pythagorean Theorem, we can say that d squared, so d squared is equal to x squared plus y squared. Do you guys agree? Pythagorean Theorem?
Yes, sir.
So there. So what I would be doing is that I would just be getting the x and y components here, and I would be doing this. So for the first part, by the way, what is the x of this first one right here? So that is to be negative 37.5. So negative 37.5. So that is to be the distance, I mean the x distance from your centroid up until the bolt that you are analyzing. So from that, our y component here is to be 75, which is this distance right here. So from here up until this point. So there, and for the second bolt, so 1 and 2. So for the second bolt, this is to be 37.5, and this y is to be 75. And as for bolt number 3, which is this one right here, so its x is to be negative 37.5, and its y component is to be 0, since it is exactly in the middle when we are to talk about the y component. So 0. And as for 4, so this is to be positive 37.5, this is to be 0. And as for this ones right here in the bottom, so 5 and 6, so they both have a y value of negative 75. And its x values are negative 37.5 and positive 37.5 respectively. So do you guys follow where these values came from?
Yes, sir.
Okay, so
Yes, sir.
so yeah, very good. So let's just get the summation of the squares of the x. So summation of x squared is equal to, so this is to be 37.5 squared times 6. Do you guys agree? So kahit naman negative siya, no, hindi na natin kailangan pang kunin yung negative symbol. It's because that we would just be squaring it, so it doesn't matter. So from that, 6 times 37.5 squared. So squared. Sabi yung squared dito. So this is to be 8437.5. So 8437.5. And for the summation of y squared, so summation of y squared, that is to be equal to, so 1, 2, 3, 4. So 4 times 75 squared. So we wouldn't be considering these zeros right here already. So 4 times 75 squared. So that is to be 22,500. Okay, since wala na naman tayong space, I would just be moving this once again to the upper right. So for the summation of d squared, that is to be the summation of y squared, I mean summation of x squared plus summation of y squared. So from that, the summation of d squared is equal to this one plus this one. So it would be, so 22,500 plus 8437.5. So our answer here would be 30937.5. So 30937.5. So erase ko na tong nasa baba since we don't need them anymore. So now that we have this value right here already, and we also have this value right here, which is t, we would now be solving for the x and y component of this system right here. So if you want to do it the long way, I mean the long cut way, so you would just be solving for each and every of these x and y components of these forces right here, and you would be adding them here for you to know the critical, I mean the most stressed bolt in the group. But by inspection, so wait lang, i-copy paste ko lang itong mga I mean ating mga tables. So this is for torsional and this is for direct shear. So there. So direct shear and torsional shear. If you would be combining all of them, so if you would be combining these forces right here with these forces right here, which do you think would give you the highest magnitude of the force or the most stressed? Can anyone guess? Would it be bolt 1, bolt 2, bolt 3, bolt 4, or whatsoever? Considering these setups right here.
Sir, bolt 2 po ba?
If we are to consider bolt 2, so kunwari, sabihin bolt 2 natin, ito. So we have our pH. So ito yung pH natin. Then we also have our PV. I'm sorry. We also have our PV which is directed upwards. So ito PV. Then meron din tayo ditong PT ng 2. Ito yung PT niya. So if you would be getting its summation of forces about this point right here, so summation of forces horizontal and summation of forces vertical, then kunin nyo yung Pythagorean niya, medyo mas mababa siya as compared dun sa isang mas mataas pa. Though mataas din yung makukuha mong value dito, pero meron pang isang mas mataas. Kasi if you would be considering tip to tail method, so ito kunwari yung tip to tail method natin, no, using physics, so ipagdugtong-dugtong lang natin sila. Yung magnitude niya is to be this one right here. So though this one is to be having a high value, etong blue line na to, meron pang isang mas mataas. Can you guess saan yung mas mataas pa kaysa dun sa 2? Though oo, mataas nga yung makuha mo dyan sa 2. Yun nga lang, meron dyang mas matindi. Anyone?
Bolt 1 po, sir.
Bolt 1. So, sige, try naman natin yung bolt 1. So, when we are to consider bolt 1, so meron tayong pH once again. pH. Then you also have PV. So, i-tip to tail method ko na, no? So, PV. We also have our PT. So, if this is to be your PT, ang maging resultant niya is to be this line right here. So, it would be this one line right here. And this line right here is to be longer than this line right here. Though hindi naman skilled yung aking ginawa, pero yan talaga yung mangyayari. So if you wouldn't be making use of the tip to tail method, instead you would just be getting the summation of forces of the vertical and horizontal components. So as you can see here, this is towards the right, this is upwards. And yung x and y components natin for bolt 1 is to be to the right and upwards. Kasi dito naman sa sa bolt 2 natin, to the right nga yung kanyang x component pero pababa naman yung kanyang y component. So your pH would be magnified but your PV would be reduced kasi nga pababa ito. So from that, si Mr. Villoria tama siya in a way na kapag ito kasing bolt 1 yung tawag dito, yung i-consider mo, getting the summation of forces about this bolt right here. So to the right, tapos pataas. Tapos ito din yung x and y component din ng ating PT. To the right din, tapos pataas din. Do you guys follow?
Yes, sir.
How about for the others? Do you guys follow? Miss Manehan, nakuha?
Yes, sir.
Miss Filio, nakuha?
Yes, sir.
Okay, Mr. Toquero, kuha?
Yes, sir.
Okay, very good. Miss Mendoza, nakuha? Kung bakit bolt 1 yung most stressed?
Yes, sir.
Okay, so ayan. And since we already know what the most stressed bolt is, we would just be solving for bolt 1 using this equation right here. So ito no, ty over summation of d squared. So dito. So sulat ko na lang siya. So for PT1x, so this would be the x component of our PT1. This is to be equal to the torsional moment, which is 3 kilonewton meter. So 3 kilonewton meter times the y component. Once again, if you are if you are solving for the x component, you must use y here. And if you are to solve for the y component, you are to use x here. So what would be the y component of bolt 1? That is to be 75. So that is to be the y distance from the centroid of the system to the centroid of bolt number 1. So that is to be 75 mm. Pero multiply, divide na lang natin to by 1,000 kasi naka-meters pala tayo dito, ano? So there, divided by this one right here, which is this one. Pero since naka mm pala yan, nagsisi ako, palitan natin pala dito. Instead of me using these values right here, 3,000 kilonewton millimeter. Millimeter na lang gamitin natin since naka-millimeters pala tayo dito sa mga parts na to. So, okay lang guys?
Yes, sir.
Nakakasunod
Yes, sir.
pa? Nakasunod pa?
Yes po, sir.
Okay, so very good. So, ito yung y component. So, times 75. So, divided by itong summation of the squares of the distances, which is 30937.5. So, 30937.5. So, solving for this, the value for our PT1x is to be equal to 7.27 kilonewtons. So, ito naka-millimeters squared to. Ito naka-millimeters. So, millimeters would just cancel out, leaving a unit of kilonewton. So, that is to be the x component of your PT number 1. So, for our PTY or PT1Y, so dito siya, PT1Y, this is to be equal to 3,000 kilonewton millimeter times the x component, which is to be this one right here. So, times 37.5. By the way, guys, mas maganda pala na kalimutan nyo muna itong mga symbols na to. Yung sign convention natin. It is better for us to use the absolute value as long as you know the direction of such force. Kasi nakakalito yung sign convention dito sa torsion eh. Kaya mas magandang ganito na lang. Gamitin nyo yung absolute value dito as long as you know the direction of your force. So, ito, papunta siya doon sa right. So, meaning, our value here would be upwards. So, ganun lang yon. Naintindihan ba?
Yes, sir.
So, ayan. So, we would be dividing this by 30937.5. And for our answer here, for PT1Y, this is to be equal to 3.63. Actually, 3.6363 yan, kaya 3.64 na lang natin. Medyo meron lang lapse itong calculator ko kasi nakapag-repeated value, pinaparenthesis niya. So, 6363 kasi yan. So, kung 6363 yan, it would be better if you would be rounding it up to the nearest hundreds, which is 3.64. So, 3.64 kilonewtons. So, this is to be the x and y components of your torsional shear. So, what would we do next? So, we would be considering both of this. So, yung direct shear plus yung torsional shear. So, we would just be getting its resultant. So, from your direct shear, copy ko lang yung ating answer, no? So, for direct shear. And as for this ones right here, this is to be for torsional shear. So, once again, the most stressed in this group is to be bolt number 1. So, meron tayong PH and PV. So, gawin ko na lang blue yung direct shear, no? So, this is for direct shear. And this one right here is to be for torsion. So, green na lang natin ngayon torsion. Torsional shear, I should say. Okay, so for direct shear, ang horizontal daw niya is 50. So once again, this is to be 50 kilonewtons. Can you see what I'm writing?
Yes, sir.
Okay.
Yes, sir.
So ayan, and that is to be 50. So this is to be 33.33. And after that, ito naman sa torsional natin, yung x component daw ng ating, di ba yung force natin kanina nakapaganito siya. So instead of getting its x and y component by sine and cosine, so since ito naman yung naibigay sa atin, idirekta na natin. So this is to be its y component, which is 3.64. And as for our x component, this is to be 7.27, which is this one right here. So 7.27. So summation of forces horizontal to get the horizontal resultant, and summation of forces vertical to get the vertical resultant, and by getting its resultant via Pythagorean Theorem, makukuha nyo na yung magnitude natin ng force. So I would be deleting this for us to have space. So for the resultant, P1, combined shear and torsional na to, no? But nawala dito, shear pala to. So for P1, this is to be equal to, so the square root of, so this is just a Pythagorean theorem. So for our y component, so that is to be this one and this one. So 3.64 plus 33.33. So this is to be squared plus your horizontal, which is 50 kilonewtons plus 7.27. This is to be squared. Guys, shortcut ko na, diniretso ko na dito sa ating Pythagorean theorem, pero kung gusto nyo pang mag-summation forces vertical and summation forces horizontal, edi mas maganda. Pero para lang mas maiksi yung video natin, edi diretso na natin dito. So from that, the value of our P1 is now equal to 68.166. So 68.17 na lang natin. So the resultant right now is to be 68.17 kilonewtons. So this is to be the magnitude of the most stressed bolt in this particular setup right here, considering this load case right here. Do you guys follow?
Yes, sir.
How about for the others? Miss Laida, nakakasunod pa?
Yes, sir.
Yan, very good. Miss Batnag, how about you? Miss
Yes, sir.
Yan, very good. Miss Gonzales, kuha yung lesson?
Yes, sir.
Okay, so ayan, no, ang sinolve pa lang natin dito is this magnitude right here. So this is the most stressed. Though hindi naman sinabi sa problem, so it is not stated in the problem that you would be designing this one right here. But if you would be designing it, so it would just be as simple as this. So if you can remember, this is to be the properties that we would be needing for our bolts. So if you can see here, meron tayong mga A307, which is the common bolt, and we have our high strength bolts, which are the following. So A325, A490, and whatsoever. But for example, that we would be using this one right here, A325M, and kunwari ito nga yung ating nominal shear stress, which is 457, we would just be determining it here. So if you can remember this equation right here, so Pn is equal to Fnv. So this is to be this one right here times the area of the bolt times the number of bolts. So if you can remember that, so dito nga, no, so sa Pn natin, yung Pn natin is to be this one right here, 68 point. Actually, hindi nga Pn to eh. So this would depend if this is, if this forces right here, so kung etong 200 kilonewtons na to and 300 kilonewtons na to, if they are, let's say, in LRFD or ito load combinations, kunwari to, this is to be PU. So magiging PU ito. And if, for example, allowable stress design yung gagamitin and this is to be service load, itong value na to, PA siya. And for example, that this one right here is to be in factored load siya. So meaning LRFD gagamitin natin. So di naman sinabi sa problem, but let's just assume that the designer, the one that who analyzed this problem used LRFD. So from that, dapat ang gagamitin natin is to be PU is equal to phi Pn. And our PU for this 1 bolt right here is to be 68.17. So 68.17 kilonewtons times 1,000 para lang maging newtons siya. So this is to be equal to phi Pn, and mawawalan tayo ng space dito, kay iurong ko lang. So ayan. So phi Pn and our phi in shear of fasteners is equal to 0.75. And for our PN, FNV, kunwari gagamitin natin is to be, let's say, 457. Kunwari nga our bolt is to be of A325 standard and the threads are excluded from the shear planes. So from that, this is to be 457 times the area of the bolt, and the area of one bolt is equal to pi over 4 times diameter squared. And if we are to design our bolts, yung D natin yung unknown, so we don't know what the value of D yet. So D squared times the number of bolt, and since we are just to analyze this one right here, isang bolt lang yung nagre-resist ng ganitong load. So that is to be 1. So solving for D right here using LRFD, so D is equal to, so looking once again to the calculator to your left, so i-shift solve na lang natin, no? 68.17 times 1,000, so alpha calc para may equal sign, 0.75 times 457 times pi, saan sabi pi dito? Times pi divided by 4 times alpha x squared times 1. So shift solve for the value of x. So that is to be 15.91. So 15.91 mm. And since we cannot buy a diameter with this specification, it is better for us to round it up to 16 mm bolts. So you would be using this one right here. Though isa lang yung dinesign natin. So in this case, we only have designed this one right here. So etong one lang yung dinesign natin. So we have concluded that we are to use 16 mm bolts for this. But how about for this number 2? Would we be designing it once again? So no. Ang i-design nyo lang dito is the most critical one, which is this one right here, and that you would be using 16 mm to all of these bolts right here for it to maintain a centroid of, well, in this one right here. Because if you would be using other bolts, so kunwari dito naka 16 mm ka, and in this one right here you have used, let's say 20 mm, and in this one right here you have used, let's say 12 mm. If you would be getting it centroid, it wouldn't be here any longer. Instead, it would be some other place, right? For example, it would be here or it would be here. And if you would be doing this, you must reanalyze it once again, and you would be redesigning it. Since mag-iiba yung eccentricity mo, and your torsional shear would be different from this one right here. So do you guys follow?
Yes, sir.
Okay, how about for the others?
Yes, sir.
Very good. Miss Mendoza, kuha?
Yes, sir.
Very good.
Yes, sir.
Yan. Miss Maneha, kuha?
Yes, sir.
Mr. Viloria, kuha?
Yes, sir.
Very good. How about for Miss Pasol, kuha naman, no?
Apo.
Okay, so ayan, so that is to be for our lesson for today. So I would just be ending the recording.